Hello, I would like to welcome all of you to our program on manufacturing design certificate within the MS online degree in mechanical engineering. My name is Nas Ghonim, and I am the coordinator of this program. So if you just have any questions or any inquiries about this specific certificate within the MS Online and Engineering program, you can contact me. I have my email, and email you can see it here, gonim@ucla.edu. And what I would like to do is give you an overview of the program. What are the requirements? What are the courses? What background should you be prepared for? And what kinds of prerequisites for courses, and how you're going to proceed through the program, and give you some simplified idea about the talents and the specializations of each of the faculty that offer courses within this program. So you will see me pop in and out of the screen, and I'll just describe the program as we go on. So I'm going to give you an overview of the manufacturing design program, and in here I'm going to talk first about the objectives of the program, courses and prerequisites, degree requirements, and maybe discuss a little bit about employment opportunities. So first, if we look at the objectives, we wanted to offer an advanced course of study in manufacturing design. And this course of study covers really a broad spectrum of both fundamental, so I'm going to outline fundamental, and advanced topics in modern manufacturing design. So you'd expect that you would have some fundamental courses related to solid mechanics, equations that relate to strength and strain and controls and so forth. So these are all fundamental sciences, but also part of the program is going to be of an applied nature, because it is to prepare you to be very effective as an employee in a big engineering organization. And the topics that we cover, they include manufacturing design of composite materials. So both, there's a course on how to make composite materials, and then another course on how to design structures with these composite materials. We also have a course on additive manufacturing, and additive manufacturing is emerging as a major process for the development of very complex shapes that do not require welding and riveting and cutting and so forth. So it's a very interesting development, and there's a course on that. And then we have a course on manufacturing of micro and nano devices, very small devices that are used as sensors and actuators in many technologies. We have a course on digital control systems, because that is an integral part of the manufacturing design process related to mechatronics, so how electronics interact with the mechanics of the systems. We have also a course on another emerging technology that is radio frequency identification. We call it wireless systems in manufacturing and design. And then we have actually two courses that relate to the role of material failure in mechanical design. And these two courses I actually teach myself, and the two courses are 296A and 296B. 296A is an upper division senior first year graduate course, and the focus is on designing of power systems. So basically a lot of work on shafts and gears and pulleys, and then how we can convert one type of motion to another, and we use finite element methods in the context of a design project. And 296B is the role of materials in component design, mechanical component design at high temperature. So the emphasis is on high temperature. So we worry about things like fatigue at high temperature, creep fatigue interaction, and how that affects the design of components in power systems or in high temperature structures for aerospace and for other applications. We also have a course on finite element technology that I will describe shortly to you. And therefore, the program will prepare you to higher education, as we believe that is necessary for today's changing technologies. So let's talk about the course requirements. The requirements is that they are multiple, so you have to satisfy the multiple requirements. So this is basically like a set of constraints. So you're playing a game that you have a constraint. So you have to satisfy, you have to take such and such 9 courses, you have to take subset of such and such courses, and then you have to also take an exam or you make a project, and it is designed so that you can maximize your proficiency in the subject field in this format. So first you have to complete 36 units, which are 9 courses, and the 9 courses do not have to be all graduate level, so that's kind of nice. So 5 of those must be 200 level, which is graduate level. The other 4 can be undergraduate, or they can be also graduate. So it depends on the specialization or the way that you want to structure your career. So you could actually choose additional undergraduate or graduate within the remaining 5 between those. But you have remaining 4, but you have to take at least 5 at the 200 level. So now we figured out the courses. Next requirement is that you have to meet a comprehensive requirement. Comprehensive ensures that you can assemble the information at a more integrated or comprehensive level. And we'll talk about this requirement in a minute. In addition, we have to have a minimum of 6 courses out of the 9 from what we call a core list. And the core list is the list of courses that would prepare you to be proficient in manufacturing design. So this is a coherent list of courses in manufacturing design. And the remaining you can obtain it basically from any course, from a list of other courses in the MAE's Mechanical and Aerospace Engineering department courses. I'll mention that. So for as far as the comprehensive, we have 2 options. Option 1 is that we have to have 8 courses, and then we can take one project course, and that one project course you enroll with any advisor that you want, and the project will be by mutual agreement between you and the advisor. So let's say if you want to do a project with me, you can tell me that I'm working at this job, and I have my boss assigned to me the design of let's say a car seat, a seat system, structures for replacement in aircraft. So this is one of the examples I give. So it's an actual design problem, but it is related to your work. Then we agree on this. Then you go through a process very similar to what you have done in the class, and then you write a short report, and then you submit it to the advisor, and the advisor signs off on it, and that would be your design project report. So this is one way that you can satisfy the comprehensive. So that cuts back 1 course, and you don't have to take any additional exams. Another way is to still take 9 courses, and then you ask 3 advisors, 3 professors who taught these 9 courses. Only the ones at the 200 level, the graduate level courses, let's say you took 6 courses at the 200 level. And from the 6 courses, you can ask Onim, you can ask Carmen, you can ask Lee, and ask each one of those 3 guys to prepare a question of a comprehensive nature and give it to you, and then you solve that question, you submit it back. If you pass, then you have fulfilled that part. If you fail, then you have another try, and then you can try on another course or the same course, and you have a total number of tries of 6. So you can try 6 times to pass 3 questions, and the 3 questions will constitute the second that will fulfill the what we call the comprehensive requirement. So this is summarized here. This is option 1 plus project, 8 plus project. Option 2, 9 plus 3 questions from the 300 level. Now I'm going to show you what the core courses are, and I'm going to discuss that a little bit. First course is design of composite structures. It's offered in the fall, and that's a May 166C. So it's an undergraduate course. Let me put myself here. So this is an undergraduate course that is actually on the design. So you need a little bit of strength of materials background, and then you will learn about the layup of composites and how you calculate stress and strain and deformation in these composite structures, and how we apply them to aircraft or automotive or other applications where composite materials are used. The second course that you see on the list here is Finite Element Technology, which is 168. And this course is again an undergraduate course, senior level. It introduces you to the basic idea of finite element, the energy, elastic energy in a structure, and how you can break down this elastic energy and use it to relate the stress to the strain in a matrix form, and how you formulate this matrix, and how you obtain boundary conditions, you apply boundary conditions. So you get into a little bit on the mechanics of how finite element is applied, and you also have the ability to use some of the commercial codes like Abacus. So this is kind of introductory level to finite element. The next course that we have is an undergraduate course, again senior level 171B, and this is digital control of physical systems. And digital control, you have to get some background on linear systems and how you would convert an analog signal to a digital signal, and how you process that signal, and how you use the signal in controls, PID controllers and so forth. So that's a subject that can lead you to be ready to do work on the design, including mechatronics. So mechatronics like robotics, something moving, and then you have some controls, and the controls is done by digital software interface. So that course can give you this background. We have a course on Introduction to Nano Micro Manufacturing, and that's this course introduces you to the modern methods of making MEMS. MEMS are micro electromechanical systems by etching and layering and chemical processes. Then what you do is that you learn how to do that, to create or to manufacture essentially sensors. So you can use that in pressure sensors, force sensors, accelerometers, and so forth. This is in everywhere. And also actuators, so you can learn how to design something that would move at the micro scale. We have now a course on the 295C, is on radio frequency identification, RFID. And that is an emerging technology where every product could have a chip, and the chip can send a wireless signal, and the wireless signal can contain any type of information on that product. So that applies to either warehousing of very large products, so you would know, a computer would know where things are exactly, or it can allow things to communicate with one another if things are not actually sitting static products, but they're actually moving. So you can apply it to maybe moving from one place to another, and networking and so forth. So that's the nature of that. So it's a lot of computer programming, a lot of signal processing, and a system level approach to manufacturing. And then we have, I offer personally two courses that I talked about, MA 296A and MA 296B. One is in the summer, which is A, and one is in the winter, which is B. So A is dedicated to systems that are rotating. So we have turbines, we have shafts, rotating shafts, we have automotive parts that are also rotating, and so forth. So it's everywhere. We must convert energy or power from one place to another, and to transmit it, usually you have this idea of rotation. So in this case, we design systems that have gears and pulleys and shafts, basically shaft design. That's the main thing. And we apply principles of material failure, material selection for the design, optimization for the entire design, and then we also take a project, and the project contains a finite element implementation on the design of a connecting rod of an internal combustion engine. And then we have another smaller project on the design of a power transmission system in the form of a speed reducer. So it's like a gear speed reducer system. So that's kind of core nuts and bolts of mechanical engineering. And then the second course that I teach, 296B, is a little bit more advanced. So you need to know a little bit on tensors and stress and strain and multi-axial systems, but the focus is going to be on plastic deformation beyond the elastic regime, high temperature deformation such as creep and fatigue, and then how we would use that in designing high heat flux components, high temperature structures in aerospace and in nuclear applications, in refineries, and in heat exchangers and the like. So these are the two courses that I teach. We have also a course on composite manufacturing, and that's 296A. That's Professor Yang teaches that, and Professor Yang is well known for his research on the manufacturing of composite materials. So he introduces concepts that relate to the how you make the mold, and how you put the fibers, and how you mix them together to put the layup and the curing process. So it's a combination of thermodynamics of materials and mechanics to have an understanding of how you make polymer-based composites, or high temperature fiber silicon carbide based composites, or graphite based composites. So all of that is covered in this course. We have a new course, 296C, by Professor Lee, and Professor Lee is in my department, and he is an area director in the area of additive manufacturing. So his specialty is to use new advanced manufacturing techniques, including nanoparticles into into manufacturing process, or nano manufacturing into the base of the manufacturing. However, this course is dedicated to a very exciting area, and this area is, in general, we call it additive manufacturing, but it is basically rapid prototyping. So you have a CAD model in 3D, and then the CAD model is fed into a 3D printer, and the printer works with a laser, or you can work with electron beams, and you melt materials and you build them up by addition, different alloy compositions, different geometries. So it gives an incredible flexibility in making materials or actually structures of very complex nature, both in composition and in the geometric complexity. Finally, I just wanted to show you a typical schedule for course schedule. In the fall, you have 166C and 297C, composites and additive manufacturing. The design of composites is taught by Professor Carmen, and his research is on ferroelectric and ferromagnetic materials, and how you can include nano and microscience in making new functional devices, functional materials. And then 296C is Professor Lee, and as I mentioned, he's nanoscience into manufacturing process. And then in the winter, you have 296B, Material Failure and Mechanic Design 2, that's myself, and it has a prerequisite of 296A. So you would have taken 296A in the summer, previous summer. And then we have 180, which is Nano and Micro Manufacturing, Professor Ju, Sontag Ju. He works in nano heat transfer. And we have also Introduction to Finite Element Technology, 168, and that's Professor Bill Klug, and his interest and research is on biomechanics of membranes and cells and the like. In the spring quarter, we have two courses. One is 171B, and this is the digital controls, and this is Professor Tsao. He is the chairman of our department, and his specialty is in mechatronics. And then 297A is composite manufacturing, Professor Yang, and he is the Associate Dean for Online Systems. He's director of the whole program, and he's in the Material Science Department, and he's been working on research on composites for many years. In the summer, you have 296C, which is the RFID systems, and that's Professor God, and his research spans smart grid and smart networks, and also RFID, and both in design and in manufacturing. And then in the summer also, you have the ability to take my course, 296A, Material Failure in Mechanical Design, and that has a requirement of 156A or equivalently 166A, because they're pretty much similar background. So with this, I think I give you kind of a general perspective on what you would expect for our program, or for this concentration within the MS Online and Engineering program. And I think you can see that the program is coherent, and it prepare you for two things. First, you'll have the fundamental knowledge that is necessary to be a very higher level engineer. So you increase your level from bachelor's level to more advanced. And the second is that we have a part of the program is applied in nature, and it gives you the tools such as finite element, manufacturing processes, practices, codes and standards and so forth. So with these tools, you'll be more desirable by employers who seek people that are specialized in manufacturing systems or in design or in a combination between manufacturing and design. So with that, I think you would have a pretty good idea and a good career if you select this program. So hopefully we'll see all of you